What can we never know? Throughout this series, we have explored the deepest mysteries of existence, the strangeness of quantum mechanics, the nature of consciousness, the fabric of time, the possibility that reality is a simulation or a hologram. We have found questions at every turn, puzzles within puzzles, mysteries that deepen the more we examine them. But today we confront something more unsettling. Not just what we do not know, but what we can never know. Are there limits to knowledge itself? Truths that no mind could ever reach? Questions that are meaningful but permanently unanswerable? Science has often surprised us, solving problems once thought impossible. But mathematics, physics, and philosophy have all revealed fundamental barriers, walls beyond which no inquiry can pass. Welcome back to the Conscious Observer. In this episode, we face the boundaries of the knowable. In 1931, the mathematician Kurt Gödel shattered the dream of complete knowledge in mathematics. He proved that any consistent formal system rich enough to express arithmetic contains true statements that cannot be proven within that system. These are not just hard problems waiting for clever solutions. They are intrinsically unprovable. No matter how many axioms you add, new unprovable truths emerge. Mathematics cannot fully capture mathematical truth. There will always be horizons beyond reach. Gödel's theorems have been interpreted in many ways. Some see them as showing the limits of mechanical reasoning, suggesting that human minds transcend algorithms. Others see them as revealing that truth outruns proof, that reality is richer than any formal description. Either way, Gödel proved that complete knowledge, at least in mathematics, is impossible in principle. Alan Turing discovered a similar limit in computation. He proved that there is no general algorithm that can determine, for all possible programs and inputs, whether a program will eventually halt or run forever. This is the halting problem, and it is undecedable. You can sometimes tell if specific programs will halt, but there is no universal method. This has profound implications. Many questions about the behavior of programs are also undecedable. If you write complex enough software, there are facts about its behavior that cannot be predicted in advance. Since much of the universe can be modeled as computation, the halting problem suggests that some facts about the universe might be inherently unpredictable. There are truths that exist but cannot be reached by any algorithm, any computation, any mechanical process. Quantum mechanics introduced fundamental limits into physics. Heisenberg's uncertainty principle states that you cannot simultaneously know both the position and momentum of a particle with perfect precision. The more precisely you measure one, the less precisely you can know the other. This is not a limit of our instruments, it is a feature of nature itself. Particles do not have definite position and momentum simultaneously. Reality is inherently fuzzy at the quantum scale. This means perfect prediction is impossible even in principle. Classical physics dreamed of a demon who could know every particle's state and predict the entire future. Quantum mechanics killed that dream. The universe contains an irreducible randomness that no amount of information can eliminate. Some future events are not merely unknown but unknowable until they happen. There are parts of the universe we can never observe. The speed of light is finite, and the universe has a finite age. Anything beyond the cosmological horizon, roughly 46 billion light-years in any direction, is permanently beyond reach. Light from there has not had time to reach us and never will, because space itself is expanding faster than light can cross it. We live inside a bubble of the observable universe, surrounded by regions we can never see, never measure, never know anything about. What happens there? What exists there? We cannot even ask meaningful empirical questions about it. And if the multiverse is real, other universes with different physical laws are similarly inaccessible, real but unknowable. The totality of existence dwarfs what we can ever contact. Can you ever truly know another mind? You have direct access only to your own consciousness. Other people behave as if they are conscious, and you infer that they are. But this is an inference, not knowledge. You cannot experience what another person experiences. You cannot verify that their inner life resembles yours at all. This is the problem of other minds, and it has no definitive solution. Perhaps everyone you meet is a philosophical zombie, acting conscious but dark inside. Perhaps their experiences are radically different from yours even if their behavior is identical. Empathy and communication provide evidence but not proof. The inner life of another being is fundamentally private, accessible only to them. You are surrounded by minds you can never fully know. The hard problem of consciousness may be the deepest limit of all. Why does experience exist? Why is there something it is like to be a brain rather than nothing? We can describe neural correlates of consciousness, map which brain activity accompanies which experiences. But this describes the outside, not the inside. No amount of physical description seems to capture the feel of redness, the hurt of pain, the taste of coffee. Some philosophers argue the hard problem is not a problem but a confusion, that once we understand the brain fully, the mystery will dissolve. Others argue that consciousness is fundamentally inexplicable in physical terms, that it is either irreducibly basic or forever beyond scientific reach. After centuries of inquiry, we still do not know whether consciousness can be explained or is the one thing that cannot be. What do these limits mean for us? One response is despair. If knowledge has boundaries, why bother? But this misunderstands the value of inquiry. The joy of exploration does not depend on reaching a final destination. Every step reveals new landscapes, even if the horizon always recedes. Gödel's theorems do not stop mathematicians from proving beautiful results. Heisenberg's uncertainty does not stop physicists from understanding the quantum world. Limits are not failures, they are features of the territory, part of what makes exploration meaningful. Knowing what we cannot know is itself a form of knowledge, perhaps the most humbling kind. It teaches us that the universe is larger than our minds, that reality exceeds any representation. Perhaps the limits of knowledge are not walls but windows. When we encounter something we cannot explain, we meet the edge of our current understanding. But edges can be explored. They invite creativity, intuition, new ways of thinking. The mysteries we have explored throughout this series, quantum weirdness, consciousness, time, existence, are not problems to be solved and filed away. They are ongoing conversations between mind and reality. Each generation revisits them with new tools and perspectives, not expecting to finish but hoping to understand a little more. The deepest questions are not answered but deepened. They are inexhaustible, which is what makes them worth asking. We have journeyed far together through this series. We have seen reality dissolve into waves and probabilities. We have seen time freeze into an eternal block. We have seen the self revealed as a construction and consciousness as the deepest mystery. We have asked whether we are simulated, whether we are eternal, whether machines can think, whether the universe is made of mathematics. And now we face the final truth. Some things we can never know. The universe keeps secrets. Reality has depths beyond our reach. But here's the wonder. We are the universe asking these questions. We are matter that contemplates matter, patterns that puzzle over patterns. Whatever the limits of knowledge, the fact that we bump against them is astonishing. You are a finite being in an infinite cosmos, and yet you can ask about the infinite. This is not a tragedy. It is a miracle. Thank you for joining me on this journey. Whatever comes next, keep observant.